Welcome guys, welcome to my channel, and today we are going to do a small kind of project. Kind of small model about the on this data set. This is not just not just a categorical problem, but there's also we use regression. So in this part of the video I'm going to first categorize that whether on depending on these all the features whether this person is going to placed or not. Okay, and in the next video I'll predict that if the person will be placed, then on the basis of again on the basis of these features, what would be his salary. So that would be good stuff. So let's first make that let me mark down and say that we are going to first predict whether a person will be placed or not. Okay, so first we'll import the important libraries. First is import numpy as np numpy as np, and again import pandas as pd, import matplotlib.pyplot as plt, and I use on Seaborn a lot, so that's why I import Seaborn as SNS, and %matplotlib inline that would be %. Okay, great. So what this all means is that this %matplotlib inline is going to give us the graphs into the same notebook. We don't have to open a new terminal for that. Unlike in PyCharm, there's a new kind of pop-up open for the images, but that's why we prefer Jupyter more, because it's far better in these kind of stuffs. So from recent few days I just get a warning after importing Seaborn, but we don't have to worry about that. So it's running. See, you can see this star, that means it's running, and also here this kind of old time clock is also showing us that it's running. So see, there's that warning which I get from few days after importing the Seaborn, but we don't have to worry about that. Now we are going to do our dataset, we are going to deal with our dataset, which is the placement dataset. So we just name it as df equal to pd dot read underscore csv, and we are going to pass placement dataset. I just put the tab here, I just hit tab and see, it gives me the suggestion. Now just run this and let's check the head of the data frame to see that how it looks like. So here we go. So this is our serial number, this is gender, this is secondary school percentage, this is secondary school board, type of board, this is high school percentage, high school board, high school stream, degree percentage, degree type, X worker, this is kind of any e-test percentage, then specialization, then MB percentage, then status. We will going to predict this thing in this video, and in the next video we are going to predict the salary if the person is placed. And yeah, that's obvious. If someone is not present, he don't have any salary. that's just obvious. Okay, so here we go. Now first few things we have to notice is that our model will take every feature as a numerical value, but see, that's not numerical, right? This value is also not numerical, this value is also not numerical, this is also. So there are 1 2 3 4 5 6 7 features that are non-numerical, and also this status is also non-numerical. So we have to deal with total 8 non-numerical features. But before that, we will first see that if our data frame here have any missing values or not. So we just say that df dot is null dot sum. So this will show us that the sum of missing values. So obviously there's no any missing value here, but yeah, down here in salary we have 67, and all these missing values are these NaN values. So from here we can easily identify that there are 67 persons who are not going to placed in this our data set. Okay, that's nice. How many persons we have? We have kind of 215, because first one is for the column names. So 215 out of 215, 67% are not going to placed. So now let's take a look at our all these features, like which are categorical. I mean, we can't classify it as categorical. First we have to see that how many values does it have. So first we'll see the gender and dot unique, so it will show us all the unique values. Here we go. So we have our male and female. That's okay. Now the next thing is, so see, we have our limited, only two different values. So this is a categorical. One thing more to notice is that if you have all the like all these values are kind of text and all of them are different, such like if I run this on another feature and it gives me like kind of 200 or 215 all different values, so there we will use natural language processing. But for now, in this case, we are not going to use this, and here's the spoiler, in this whole model we are not going to use that. Okay, so next is DF of first we see the gender, then we see the secondary school board type. Dot unique. Let me just copy it for further use. So here we go, there are only two type of boards, others and central. Next value is high school board. Let's see. So there's again only two types of boards, others and central. Next is our high school stream. So I'll just do it, high school stream. So there are three streams: commerce, science and arts, and that's interesting that this company is going to take all kind of students here. I don't know what kind of job it is. Okay, next is the degree type. So let's see how many type of degree we have. Degree underscore T. So we have three types of degree here. This is science and tech, commerce and management, and others. So basically this science and tech refers to the science students, and commerce and management refers to this commerce students, and arts for others. I'm sorry, art students, that's not for you guys. Okay, then work X. Let's see how many values are there in work X. I guess there would be two only, yes or no. Yes, I can just see that there only no yes, no yes. And then the spatialization. Okay, so let's just see one more thing, that if I do SPE and hit tab, it will auto-complete it. That's the coolest thing about the Jupyter Notebook. So we have marketing and human resource, and marketing and financial. I don't know about both of them, but you can see that there are only two specializations we have available here. And the last is status. So let's take a look at the status. DF of status dot unique. So only two status, either placed or not, and obviously there couldn't be any another case here. So we 512. Okay, so did we just deal with all these things? 1 2 3 4 5 6 7 8. Okay, perfect. So we just deal with all the different things. 1 2 3 4 5 6 7 8. Perfect. Okay, now I'm going to remove all these cells just to make our code smaller, so that you guys won't worry about seeing the size. I'm just you can just delete it. That's just for your knowledge. Okay, now what we have to do is we are going to make the dummies of these numerical values to these categorical values, to change it in numerical, and these numerical values are as it is. Okay, now one more thing is to notice that this serial number doesn't give us any special idea about if someone is going to placed or not. Okay, so it's not like any game like the fourth person has the highest probability to get not placed or something like that. So we will just simply drop the serial number, because serial number logically that doesn't make any sense here, right? And if you want to put it as it is, that's your choice. I will give you the link for this data set. if you want to, then just write down in the comment, I will give you. Otherwise you can work on any model. This is just for complete beginners who just know the basic knowledge and didn't yet implement any project. Okay, now next thing is we are going to make the dummies of all these variables. This is gender, secondary school board, high school stream, degree percentage, degree type, work X, and specialization, and also this status. So just make it. So let me just add another mark down here, and I just write it making dummies. Okay, perfect. Now we have our dummy variables as gender, and there are a lot of things. So first we will make a gender data frame here, and we use the pd dot get underscore dummies. See, I use tab to autocomplete it, and I use df of gender from, and use the drop first equal to true. Why I use drop first equal to true? That's because let me explain it clearly. So if I do this and call the gender, so here we go. So that's the data frame we got. This is female and male. Now I know you are smart enough to find a thing here is that this, if someone is female, then that's probably not going to be male, and if someone is male, then that's not going to be female. So that's why that just makes some obvious sense. So we just drop one row, drop the first row, and put it as true. And almost in all the cases we are going to do this. Okay, now if I call gender, so that shows me that if someone is male or not. If not, then she should be female. Okay, here we go. So we made the gender, and similarly we are going to make the boards underscore 10th equal to pd dot get underscore dummies, and I'll just pause it and continue in a while. No, you can just skip it. I'm not going to pause that. Gender ss secondary school board, comma drop underscore first equal to true. Then what's next? We have boards 12th. Whoa, that was, my 12 boards were really bad. Dummies of df of HSC board, and I use again the drop first equal to true. Then what's next is stream, pd dot get underscore dummies, df of HSC underscore s, true. What's next? We have degree type, so we just see the degree underscore type is equal to pd dot get underscore dummies, df of degree t, and just say drop first equal to true. What else we have? Work x, so I just write work x equal to, you can name it as though you don't have to rename it just like that it was here. You can rename it as you like to, but for the sake of simplicity I just did that. Dummies of df of this work x, and again I'm going to do the drop first equal to true. Now what's next? We have the specialization. specialization pd dot get dummies of df of specialization and drop first equal true, and the last is the status of pd dot get underscore dummies of df of this last status, and we just say again that drop first equals true. Perfect. So we have 3, 6, 7, 8. Okay, so we have all our these values, and now we just run this. So we just get all the different values. Now what I have to do is I'm going to concatenate all these values inside this data frame. So how we are going to do that? We are just called pd dot concat, and I pass a list here which is df, then the gender, then ports 10th, then ports 12th, then stream, again is degree type, workx, specialization, and status from axis equals 1. Okay, now so this is a new data frame, and we are going to store this data frame back to our old data frame, which is df. You can name it as any other, but I found df quite comfortable to write. So now just check our head. Here we go. So this is our head, and now we just see that till now these new values are attached to the data frame. We just say mail others. Okay, now one important thing to notice here is, see, we have 3 other columns here. First this one, then this one, and then this one. Okay, where we got from this value? This is from the 10th boards, this is from 12th boards, and this is from the degree type. So which is the commerce, there is science and tech and something like that. I didn't remember. But now we have a new problem here, and that's not a problem actually. But yeah, we should notice that there are 3 similar name columns here. So what we can do is we can call just df.columns and run this. So these are the columns. Now I'm going to copy all this from here. Okay, great. And now I just say that df of columns is equal to all the values the same, but the first others would be others underscore 10, others underscore 12, and others underscore degree. Here we go. Now if I run the df.head, whoops, here we go. So now we just solve our problem. Okay, now one more important thing to notice is that now I'm going to remove it, because that we just use head a lot of times, but now you know the purpose of using that. Okay, now what we are going to do is we are going to remove the unknown. First let me show you again the head for one more time. Now is this important? I guess no, because I already explained it that serial numbers doesn't actually matter to this if someone is going to place it or not. So we are going to drop this. Okay, now tell me, this gender is important now? Yeah, it was important, but now is that important because this is categorical value. This is a string and our model will not identify this and throw us an error. So we just use this gender to this thing, male. So now this is no longer in use. This is also no longer in use, and all the other stuffs which we changed. So now we're just going to say that our new df would be old df, which is going to drop some new some things like serial number, comma gender. Now you can skip the video to see all this typing. Secondary school board. I guess you are skipping everything, so that's why I'm just relaxed now. high school board, high school stream, degree type, work X, specialization. That's it, I guess, and the status obviously. Status from X is equals to 1. That is, we have to remove all this from these columns because there's no any such names in the rows. We have 0, 1, 2, 3, 4, so that's why. Now let's run this. Here we go. Now we just say our df.head. Here we go. So we got our complete values, complete data set which we needed. Okay, now is the salary needed? No. But why didn't we drop it? Because there's an option. We can also just do our further process by considering all of them in the data frame, but that's just to make data frame more pretty now. Now there's just nice numerical values here. Okay, now what we do is we are going to do that. The salary, we are going to leave it. So let me make an X, which is the column of features, and from X we are going to do something like that. df.drop the salary and the placed. Now what I did is I just took all the things but except this one, this salary and this placed, because placed is what we are going to predict and salary is no longer used for us in this case. And we are going to drop it from X is equal to 1 and store it in X. Now if I print X, you can see the values. So these are the column, these are the feature columns or the features. Similarly, I just say small y is equal to, and in y we just store what we have to predict. So y placed. That's it. Now our machine learning, now everything would be very easy. I just say that from sklearn dot model selection import, I just hit the tab, it's running, you can see it over here. It will show me, now it's done. Now I just say x underscore train comma x underscore test comma y underscore train comma y underscore test is equal to train test split, and we pass the x, y and the test size which we want our model, our whole data set to be splitted, and I just say 0.25, 1/4. We just keep 1/4 of the whole data set as completely isolated from our training model, and I just use the random underscore state is equal to 12. I usually use this. You can use anything. Usually in a lot of videos you will see people using this, but I use 12. That's up to you. You can take anything. Here we go. Now we are going to train all these models, but before that you can do the data pre-processing part here, and that's totally up to you if you want to do the data pre-processing. But yes, I suggest you, if you do the data pre-processing, you will get better results. But I'm skipping that part, and if you want to see the data the scalarization of this whole data set, then I will post another small video that would be only 2 or 3 minutes long. But now I just already took 24 minutes, so now let's get further. And now I say that from sklearn dot linear model, first we will use the logistic regression, import logistic regression. Now I say that model equal to logistic regression. Now I say that model dot fit x underscore train. We are going to just now train our model on the training set. Here we go. you don't have to worry about these are for the future. Further, see, it is a default solver will be changed to this one in the next update, so you don't have to worry about that. Now we just say that y underscore pred, oops, this is prediction, and I just say the predicted values would be model dot predict. What is going to predict? The x underscore test. This test feature is completely isolated. You remember this 1/4 of the whole data set? That's our test feature. And if I'm going to see that y underscore pred, so that would be this array. And if I say y underscore test, which we keep as the result, it is like this values. So there's one little thing I have to do is I have to take these values, dot values. Here we go. Now we see that both are in same dimension. Here we go. So see, there are some values which are not exactly same, but let's see how many of them are same or not. So I just say that from sklearn dot metrics import. Now what we are going to do, we are going to import the classification report and the confusion matrix. Now I say that print the classification report of y underscore test and y underscore pred. Remember, you have to give the true values first and then the predicted values. And now we are going to print the confusion matrix of y underscore test and y underscore pred, again in the same manner. Here we go. So we get 85% of accuracy. Accuracy is 85%, and all these values are good, quite enough. And see how our model proves that out of 10. So our model just say no to 10 models, to 10 values, which are actually no. If you know about the confusion matrix, so this is no, yes, this is no, yes, this is predicted values, this is real values. So it says no here, and the true value is no. So these all values are same. In 8 cases, it's a yes, machine predicted yes, but in actual that's no. So these are the 8 cases which are wrongly predicted, and all these 36 cases which are yes and which are actually yes and our model predicted yes. So these are the true values. So the diagonal elements here are the heroes, and non-diagonal elements are the villains actually. Okay, now let's try on any other model. Let me use neighbors, the nearest neighbors. Import k-neighbors classifier. K-neighbors classifier, and we just set the n classifiers as it is. So we get 83%. That's not very good value. And let me just do something here. There you go, 85%. Okay, that's, I just use a random value just to check anything. Okay, so we got 85% of accuracy, which is not quite bad, but that's also not that great. So now finally I use my favorite one, which is ensemble. Import the random forest classifier. And I just use the n estimators as 27. I guess I just use random values because I like to do this. Okay, so here we go. We get a very good 91% accuracy, and that's very good. So I prefer this model random forest classifier for this whole data set. So let me run the whole data set once, or just leave that. So here we go. That's our we just predicted 90 out of 10. We predicted 9 values as true, that either he's going to select it or not. So that's quite good actually. So that's how you're going to implement your first model. And see here, we just predicted 5 wrong values, and all these are our diagonal elements are heroes, and these are the villains. So we just did a good job. So congratulations if you are make till here, and hope you like the video. That's a kind of long video, and I hope you understand everything. If you have any doubt at anywhere, then please feel free to ask in the comment section. And sorry, that's my very first video, so, and actually not the first video, but that's first video in this complete tutorial, so that's why I'm not that much confident. But yeah, and sure, in future videos I'll be in the form. So in the next video we are going to predict the salary if a person is placed. So we are going to continue up to this in the next lecture. So thanks for watching, guys. If you like the video, then please like the video if you understand everything, and if there is any little doubt, then please feel free to write the comment, and also a little appreciation would be great in the comment box. And please subscribe the channel if you need more machine learning and deep learning stuffs in future. Thank you so much.